Yeah, hello everyone. In this video, I am going to discuss about matrix of linear transformation. If you are having some linear transformation, then how you will calculate matrix representation of that linear transformation. So basically, we know that uh, a matrix linear transformation from each and every linear transformation we can get a matrix, and uh, from a matrix we can get again a linear transformation. So we are having three cases. Sometimes you will be asked to calculate linear transformation with respect to standard basis. Sometimes you will be given to you calculate matrix of linear transformation with respect to some other basis like 1, 2, 2, 5. So this is second type of question. Third type question, you will be given two bases alpha and beta. Alpha is different and beta is different. Then you will be asked to calculate matrix representation from alpha to beta and beta to alpha. So these three type of question is possible based on this concept. So I will be discussing one by one. If you are having, you have to calculate matrix representation with respect to standard basis, then how to calculate? So here I have written, easily you can look at here. First question I have taken t from linear transformation to r square to r square, and t of x y is given 2x plus 3y, 4x minus 5y. So first of all, because linear transformation is defined from r square to r square, so we know that standard basis of r square is what? 1, 0 and 0, 1. So first we can calculate what is image of 1, 0. 1, 0 means x component 1 and y component is 0. So x component 2, y 0. So 2 comma, we can get 4. And one thing you just keep in mind, what image we are getting, this we have to represent in the linear combination of 1, 0 and 0, 1. So this we can write 2 times 1 comma 0 plus 4 times 0 comma 1. Similarly, what will be t of 0 comma 1? T of 0 comma 1 will be what? This equal to, now x component 0, y component 1. So x component 0, so you will get 3 and comma minus 5. Again, this output means this image we can represent in the linear combination of the given basis. So 2 times 3 times 1 comma 0 plus or minus we can write, because here we are getting minus. So minus, so this we can write minus 5 times 0 comma 1. So what will be matrix representation of A? So this is very simple. So A we can write what we are getting, these vectors, this 2, this 4. So these two vectors we can write in column wise. So we can get here 2 comma 4, and this 3 minus 5. So we can write here 3 and minus 5. So like this, we can calculate matrix representation with respect to inner this standard basis. So this will be the matrix representation with respect to standard basis. Again, if you want to calculate same linear transformation, so this matrix we can take here. This matrix we can take x comma y. If you will multiply x comma y, then what you will get? First component, this equal to 2x plus 3y, and second component 4x minus 5y, and which is given our linear transformation. So from every matrix representation we can get linear transformation, and from every linear transformation we can get matrix representation. So in case of standard basis, your work is very easy. Simply we can calculate output, and that output we can write in the linear combination of given standard basis, and these vectors we have to write in column wise, not row wise, because if you will write here 2, 4 and 4 minus 5, and you are going to multiply with xy, so we are not going to get this original given linear transformation. Now second case is given, if suppose the given basis is not standard in a product standard basis, then how you will calculate? So now I am going to calculate b part. So b part is what? B part we have to calculate what are the bases given. First you write down second basis is given v equal to 1 comma 2 and 2 comma 5. And given linear transformation is what? Once again, I will write here. Given linear transformation, T of x, y is what? 2x plus 3y, comma 4x minus 5y. So, what to do? Again, the basis element, given basis element, we can find image. So, what will be image of T1 comma 2? So, 1 comma 2 image, easily you can calculate. T1 comma 2 means what? Here, we can get x value 1, y value 3. So 3 into 2, 6 plus 2, we can get 8. And second component 4 minus 10. So 4 minus 10 is nothing but 8 and minus 6. So now this image again we have to write in the linear combination of 1 comma 2. So because there are two vectors, so corresponding first vector we can take 1 comma 2 plus corresponding second vector we can get b of 2 comma 5. So what you similarly t of 2 comma 5 will be what? T of 2 comma 5. X value is 2 and y value 5. So easily we can calculate. So this will be what? 2 comma 5. So 4 plus x value is 2 and y value is 15. So you can get 4 plus 15, which is nothing but 19. So this will be 19. And when you will put in the second component, 4 into 2, 8 minus 25. So minus 25 plus 8. So we can get minus 17. So this value we can get 17. And again, same vector we can write in the linear combination. So because first time we have chosen a scalar a and b, so this time we can choose a1, again 1 comma 2 plus b1, 2 comma 5. So from the first we can get first equation, first component a into 1, so you can get a plus 2b, a plus 2b equal to a, and second equation 2a plus 5b, 2a plus 5b, this equal to minus 6. So now these value you can solve these two equation and we can calculate a and b. So a value we are getting, you can verify. A value is 52, a value is 52 and b value is minus 22. So this we can verify because here a value is 55 and here 2 into b. So what you will get? 52 minus 22 into 2. So you will get 44 and 52 minus 44 is what? 8. So these values are satisfying the given condition. Similarly, we can calculate a1 and b1. A1 value, you can calculate a1 value is 129. A1 value is 129 and b1 value is minus 22. This also we can verify A1, B1. So now after getting A1, B1, so what we are getting A, B and A1, B1, we can write in the column wise. So what will be matrix representation of T with respect to the basis? This matrix representation A. This we can write AB. What is value of A? So always remember this AB we have to write in the column wise. So A is what? 52 and B is minus 22. A1 is what? 129 and B1 is what? Minus 22. So this will be matrix representation of the given linear transformation with respect to basis 1, 2 and what was given? Basis 1, 2 and 2 comma 5. So this is the way if you are having standard basis, our work is very easily we can calculate. If you are given two different bases, so we can find image and that image we can write in the linear combination of the basis vector. We can calculate scalars and that scalars we have write down in the column wise and we can get matrix representation. Yeah, next problem is given. We are having one linear transformation T of x, y, z equal to 3x plus 2y minus 4z. x minus 5y plus 3z. So easily we can see here, easily we can claim that T is a linear transformation from r cube to r square. So this time if you will observe here, we are having two bases, alpha and beta, and here clearly they have mentioned we have to find matrix representation of T from alpha to beta. So what is meaning of alpha to beta? So we have to calculate image of alpha. So first we have to calculate what is image of 1, 1, 1, and that image we have to write in the linear combination of beta vector. Similarly, we have to calculate image of the second component 1, 1, 0, and again then that image we have to write in the linear combination of beta. Similarly, we can get image of 1, 0, 0, and again we can represent in the linear combination of beta. If suppose you are getting matrix T from beta to alpha, so in that case we have to repeat same process but in reverse order. So now from beta to alpha, now we have to find image of 1 comma 3, and we have to write in the linear combination of 1 1 1, 1 1 0, and 1 0 0, and then again we have to find image of 2 comma 5. Again that image we have to write in the linear combination of these things. So alpha to beta and beta to alpha, you have to remember alpha to beta. So this arrow you have to, this given arrow, this will indicating you, we have to write alpha, we have to find image, and that alpha we have to write in the linear combination of beta. Why we are doing this one? Because you are looking here, alpha is the basis for this r cube. So if I am applying here T of alpha 1 1, so if I am going to apply T alpha here, so T alpha will be the member of R2. So T alpha is the member of R2. Now we know that because these are the bases, so any random vector of R2 can be written in the linear combination of 1, 3, and 2, comma 5. Similarly, 1, 1, 0 is also member of R cube. So again, from the concept of basis element, image of 1, 1, 0, again it can be written in the linear combination of 1, 3, 2, 5. So now I am going to start the process. So what will be image of 1, 1, 1? So first we calculate what is image of 1, 1, 1. So simply we can calculate image of T of 1, 1, and 1. This will be what? First component is given 3. Second component is 2 minus 4. So 3 plus 2, 5. 5 minus 4. We can get here 1. What will be second component? X minus 5y plus 3z. So x is 1. 1 minus 5 plus 3. So 1 plus 3, 4 minus 5. So we can get 1 minus 1. And this image we have to write in the linear combination of beta, and beta having two vectors. So we can choose A 1 comma 3 plus B 2 comma 5. Similarly, second basis element T110, this will be what? X component 1, Y component 1, Z component is 0. So 3 plus 2, 5. We can check 3, X component 1, Y is 1. So 3 plus 2, 5, and Z is 0. So first component you can get 5. Second component 1 minus 5. So minus 4. And this, because A and B we have chosen, so we can take here A1 1 comma 3 plus B1 2 comma 5. Similarly, what will be image of T100? So T100 will be what? X component 1, Y component 0, Z component 0. So we can get here 3 and 1. And this again we can write because A1 and B1 you have taken. So next scalar we can choose A2, B2. This we can write A2 1 comma 3 plus B2 1 comma 3. So now again our target is to calculate A, B, A1, B1, and A2, B2, and this A1, B1 we can write in the column wise, and we can calculate matrix representation. So A and B will be what? So we can calculate A, B. So first equation what you will get? A plus 2B, A plus 2B, this equal to what? 1, and 3A plus 5B, this equal to minus 1. So after solving these two value, we can calculate A value. A value is 7 minus 7, and B value is 4. So let's get these two value we can satisfy. So A value is minus 7, plus 2b, 2 into 4, 8, 8 minus 7, 1. So correct, 3a minus 21 plus 20 minus 1. So these two values are correct. Similarly, we can calculate a1, b1. So a1 value, a1 value is minus 33 and b1 value is what? 9, 19 and c1 value is minus 13 and c2 is what? 8. So this is very, very simple to calculate matrix representation of a linear transformation. If you are having one basis, standard basis, it's very easy. If given two different bases, so alpha to beta and beta to alpha, this arrow uh, you have to follow. If alpha to beta given, then image of alpha should be written in the linear combination of beta. If beta to alpha is given, then image of beta should be written in the linear combination of alpha. What will be matrix representation of the given linear transformation? These a1, b1 we can write in the column wise. So minus 7, 4, minus 33 and 19, minus 13 and 8. So only these three type of question we can get in matrix representation of linear transformation. So next topic, now I am going to discuss about change of basis matrix or transition matrix. This is known as if you are having two different bases beta and alpha. So how to calculate transition matrix from alpha to beta and from beta to alpha. So we are having, if you will look at here, alpha is given 1 0 0, beta is given 0 1 sorry 1 0 1 0 0 0 1, and beta is given 1 1 1 1 0 1 0 0. There are two bases alpha and beta given. So now we have to calculate change of basis matrix or transition matrix. This is both same. P, and this matrix is known as a P, and Q matrix is from beta to alpha. This is also known as a transition matrix from alpha to beta and beta to alpha, and the obtained matrix is known as Q. So how to calculate this transition matrix if you are having two different bases? So first matrix change of basis transition matrix P from alpha to beta. Again we have to follow the given arrow. Alpha to beta means what? Alpha vector can be written in the linear combination of beta vector. So what is first vector of alpha? 1 0 0. So this 1 0 0 we have to write in the linear combination of beta vector. Now how many vectors are given in beta? 3. So accordingly we can choose three scalar A 1 1 1 plus B 1 1 0 plus C 1 0 0. So we can calculate similarly T of second vector is what? Alpha 0 1 0. So this 0 1 0 again you have to write in the linear combination of given vector. So this time we can choose A1 1 1 1 plus B1 1 1 0 plus C1 1 0 0. Similarly third vector is given 0 0 1. So 0 0 1. This we can assume that A2 triple 1 plus B2 1 1 0 plus C2 1 0 0. So now again our target is to calculate these A, B, C and A1, B1, C1, A2, B2, C2. So again from the first equation what you can get? From the first equation you can get A plus B plus C, this equal to what? 1. And second equation you can get A plus B, this equal to 0. And third equation A B into 0 0 C into 0 0. So we can get A equal to 0. If A equal to 0, then B equal to also 0 and C equal to 1. So similarly you can calculate other values A1 B1 C1 and A2 B2 C2. So what is value of A1? Yeah, A1 value is what? 0 and B1 value is 1 and C1 value is minus 1. Similarly A2 A2 is 1, B2 is also, B2 is -1, and C2 is 0. So we can verify these two values. Here, if I will solve second equation, so A1 plus B1 plus C1 equal to 1, 0. And second equation, so what will be matrix represent this change of basis matrix P, which is known as a P. So again, these as now I explained this matrix representation, we have written ABC in the column wise. So this also we can write in the column wise. So what is value of ABC? So we are getting 0, 0, 0 and 1. Again, we have to write in the column wise 0, 0, 1. Second, we can write 0, 1 and -1. Third, we can write 1, -1 and 0. So this is P matrix. Now, if we have to calculate transition matrix from alpha to beta, we have calculated, and we have to calculate now beta to alpha. Second case, we can calculate transition matrix Q from beta to alpha. So same process you have to apply in the reverse order. So now what is beta vector? Beta alpha vector, beta to alpha means what? Now beta vector can be written in the linear combination of alpha vector. So what is first beta vector? 1, 1 and 1. And this can be written in the linear combination of alpha. And in alpha, what are the vector? Standard basis. So A1, 1, 0, 0 plus B1, 0, 1, 0, 0, 0, 1, 0 plus C1, 0, 0, 1. So this directly we can calculate because first component you will get A1, B1, C1. So directly we can write A1 is 1, B1 is 1, and C1 is also 1. Similarly, you can write second vector. In second vector, we can calculate A2, B2, C2, A3, B3, C3, and then you can obtain Q matrix 1, 1, 1, 1, 1, 1, and 1, 1, 0, 1, 1, 0, and 1, 0, 1. So this is transition matrix Q. So if you have to calculate transition matrix from alpha to beta, then you remember alpha vector can be written in the linear combination of beta, beta to alpha, then beta vector can be written in the linear combination of alpha vector. And also we have one result. These two matrices P and Q are associated. This P equal to Q inverse and Q equal to P inverse. So what transition matrix just now we have obtained? So what is the relation between this P and Q? P is equal to Q inverse. So if you will multiply with P and Q, so we can get P into Q equal to what? Identity matrix. So sometime you can also, you can be asked, prove that P equal to Q inverse or Q equal to P inverse. So we can prove that product of P and Q are the identity matrix. In next lecture, I will be discussing about similar matrices. Thanks for watching.